Okay, sorry, video's starting again. So we just plug in now -1. So what is the slope at x equals -1?
4.
Yeah, so you'd have -4, right?
Yeah, negative 4.
And how about at x equals 0? It just do f prime of 0, and so I just get 0. And how about at 1? It'd be +4. So think about this graph. X to the 4th. Do you guys know what x to the 4th looks like? Guesses? What the graph of x to the 4th? Yeah, it's going to be going up on both sides, right? It might have some wiggle in the middle, or it might just come down like a parabola, right? Something like that. And so it makes sense that over here at -1, we're going to have a negative slope on the left side. That at 0, I would have a slope of 0, and that up on the right side, I would have a slope of +4. So that kind of makes sense there, thinking of that graph. Okay. So now, again, it's going to make your life a lot easier to find the equation of a tangent line. So let's find the equation of this tangent line. All right, well, let's do the derivative. Derivative, 2x. Derivative is going to give me the slope. Okay, so slope of my tangent line is 2x. I have to plug in -2. So my slope is -4. That's my slope. Well, I need to write the whole equation of the tangent line, though, so I need point-slope form. So I would do y minus y1. What's my y1 value here? Y minus y1. We know the slope is -4. So what are my x1 and my y1? Your x1 is -2, because that's the point we're talking about, right? So this would be x plus 2. And then how am I going to find y1?
Positive.
How are you getting that, Nick?
I don't know. It's up, or you can just plug it.
He's like, it said it on your answer key, Mr. Rodrigo.
Well, no.
I plug it into what? That's my
Plug it
question.
into X squared.
Plug it into the original equation. Yeah, if I think about this, you guys, this is the original graph. It's this parabola, x squared. I'm looking at -2, 4. I want the equation of this line. So we know the slope was -4, but this point is what I'm looking for. And so I have to plug that -2 back in here to get that y value. So the y value would be -2 squared, which is +4. All right, it didn't say to put it in slope-intercept form, so I'm not going to move anything. I'm going to leave it as is. Moving stuff around just means more chances for me to make mistakes. So if I'm not going to force you to put it in slope-intercept, just leave it like that. If it's a multiple-choice question, you might have to move it around. But again, so much easier now to be able to find the slope, find the equation of your tangent line. Life is good, people. All right, turn the page. So what happens if we're multiplying by a constant? So notice these, like 3x, 2 over x, 4/5 t squared, 2 times root x. So they have these constants or coefficients in front of them. Well, nothing. The rule still works. Power rule still works. All that you're going to do is you're going to, when you bring that exponent in front, so this is like x to the first, when I bring this exponent in front, it's just going to now multiply with whatever number was out there originally. And so my y prime would just have 3x and then subtract 1, so that's to the 0. So that's just a 1, so this would just be 3. Okay. Again, before you differentiate, move any variables that are in the denominator, move them up to the top, then do your differentiation. Okay, so that x, I will move it up to the top, so this equation will become 2x to the -1. Now I can differentiate, power rule, move the -1 in front, multiply it by the 2, then subtract 1. So you should get what? -2x to the -2. Let's rewrite that, positive x. So -2 over x squared. Make sense? 4/5 t squared, what are we going to get? All right, so it would just be 8/5 t. Does that make sense? Take the 2, move it in front, multiply it by the coefficient that's already there, subtract 1 from your exponent, power rule. 2 root x. What should I do with that root x first?
Turn it into a fraction.
Turn into a fraction. So x to the 1/2. Good. So I would have 2x to the 1/2. Power rule. Move it in front, multiply it, subtract 1. So I would end up getting 1x to the negative 1/2. Rewrite it. Does that look good? In the denominator and square root. It's a fun one. So try this one on your own. Sure, try it. See what you get. I'll do it up here, but don't cheat. See if you agree with me. You should probably check my answer. Yeah, we're good. Did you guys get that?
Yes.
Negative 1 on top over 3 because the 2's canceled. And then negative 5/3 just gets rewritten as the third root of x to the 5th. Right? Denominator becomes the index of my radical. The exponent is what the numerator is, right? All right, the last one's a little easier. You should just get negative 3/2. Done. Perfect. Negative 3/2 times 1, x to the 0. Okay. All right, we're going to just practice a whole bunch more with this. This is really, the rest of notes here are just a lot of practice. Hi, that was quick.
Yeah.
Dumb, pointless.
Yeah.
Yeah, it wasn't very moving.
No, it wasn't.
They said someone got hit by a car and that's it.
It's not moving. Hurts
No,
hurted.
like the way the girl was talking about it, she's like, it was 12 in the morning and she was going home from the house.
Okay. I'm recording, by the way. You just got that all on. It's all right. Nobody knows who you are. It's all good. All right. So if you want to, this might be a little easier to write these like a chart sort of thing here. Okay. It's all right.
Good job.
Glad you're back. We're on page 97 if you want to pick up where we're at here. So again, rewriting, move that x to the top first, and then just do your power rule, okay? So you're going to have 5 halves x to the negative 3, and then differentiate just means do the power rule, okay? So take your negative 3, move it out front. So I'll have negative 3 times 5 halves, subtract 1 to the negative 4th, and then rewrite everything. So negative 15 over 2x to the 4th. And this is equal to y prime. Okay. On letter B, my hint would be to work this out first. So this 3 really distributes into each of those first. So this is more like 5 over 2 to the 3rd x to the 3rd. So it'd be 5 over 8 x to the 3rd. Then move it up. Right? And now do your whole differentiation thing. All right, go ahead and work through the rest of them and then check your answers up front here. All right, I'll put up the other ones. Go ahead and work through them first and then look up to check. See how I did. Power rule?
I don't know if I broke it home.
Okay, how'd we do? Yes? No? They're okay?
Yeah, fine.
Pretty good, right? Can I move on to the next page? I think I'm almost done. I just have one little thing to teach you guys, and then that'll be it, okay? One more little section. I'm not going to finish all the notes today. We'll do the second part tomorrow. We do good, okay, on these guys? We're fine? Okay. 30 minutes? Maybe. It's like a blue late start-ish. Like a little less even, I want to say. So it's short. All right, so what happens if I don't just have one term, right, in one of these functions? So what if I have something like x to the third minus 4x plus 5? So I've got like a polynomial with multiple terms in it, or like something like this, right? Well, the nice thing about doing power rule is that it will carry over through sums and differences. So addition, subtraction, all you're going to have to do is take the derivative of the first one, then the derivative of the second one, the derivative of the third one, and it just follows the same rules, okay? Once we move on, like next year, when you guys pick this up next year in calculus, you'll talk about what happens if you multiply two functions. You can't just multiply their derivatives. That doesn't work. So for multiplication and division, it doesn't cross over. But if you're just adding functions or subtracting functions, power rule will cross over. So it's pretty easy. The derivative of f of x plus g of x is just f prime plus g prime. Same thing with differences. The derivative of f of x minus g of x is just f prime minus g prime. Okay? So here we go. Let's just do this. You're going to do the derivative now. So we're trying to find the derivative of the whole thing. So I do one at a time. What's the derivative of x cubed?
3x squared.
3x squared. What's the derivative of negative 4x? Just negative 4, right? Because it would be negative 4 times 1, x to the 0. So just negative 4. What's the derivative of 5? 0, constant rule. And so my derivative is just 3x squared minus 4. Nice and easy, right? So much easier than the other way. All right, so same idea here. Go ahead and take the derivative of this. So bring your 4 in front. So I'd have negative 4 halves, x to the third. 3 times 3 would be 9, x squared, minus 2 times 1, 2. Simplify this a little bit. So negative 2x cubed plus 9x squared minus 2 would be g prime. And we are done. That's where I'm stopping today. Tomorrow we'll pick up with sine and cosine derivatives. I just don't want to do too much. We'll just stick to just power rule for today. Tomorrow we'll do the trig stuff and a little velocity physics stuff for all of my physics lovers out there. And my sophomores that have no idea what I'm talking about. All right, I'm stopping video.